Right. This is the one that we were discussing last day. You said that you have a problem in the fourth row. 1, 2, 3, 4. Actually, so first of all, let me tell you the trick here. So last time also we have learned that I asked you to extend that lines, right? I think you can remember. I asked you to extend the line because that is how we get to know about the number of cells which are merged. So you can simply extend these lines like this. Okay. If there are any line, you need to extend horizontally and vertically, both ways, right? Here also, there's a line. This one is here. And there's a line here also. And here also there's a line. And this line you have to extend downwards too. Not just the upwards, you have to extend the downwards. This line too. Sorry, that you need to extend downwards. And this too. Need to be extended. Because then it will give you a clear picture about what you are going to create, how many rows and how many columns. Easily you can count after this. Okay, I hope that I have extended all the lines. Oh no, not all. Now I guess yes. How many rows in this table? How many columns? Let's count. Yes, how many columns? How many columns?
7.
1, 2, 3, 4, 5, 6, 7. How many rows?
6.
1, 2, 3, 4, 5, and 6. Okay. Now you have 7 rows. Oh, 6 rows, 7 columns. 6 rows, 7 columns layout. Okay, good. Let's see that now. Right? So then the next step is create this one. The next step is creating this one. So let's use brackets, or you can use Notepad or Notepad++, anything. Like today I will suggest another one, right? You can use Notepad++. Let's download that and use that for future coding, because now you are somewhat familiar with Notepad now. So we can try Notepad++ today. Okay, because that will help you, that will color the syntax. You can start with HTML tag and HTML closing tag same time, because otherwise you will forget. So this method is easy because you will never forget to close a tag. Then the title, open of the title in title tag and the closing of that. And then hello world. Body tag, and then the body tag closing. Right, good. Then the table tag. Here you have to tell the figures. So what is the width of this table? You can see here 960. From here to here 960. Here this one is okay, is it 40? No, 40 is the height, it seems. Let's keep 960 and maybe, okay, we don't know this. Let's put X. We don't know X here. Same gap here, X. Same gap here, X. But in the middle, it is 960. So it should be something more than 960. So my plan is to give, okay, width. So let's give 1160. With this 1160, because we can allocate 100 for this and 100 for this. That is depend. And then let's add a border of 1 pixel to see the lines. Let's close the table tag. I hope this is clear to you. Is there any doubt on this point?
No.
No, good. Then the first row. First row, how many cells merged? 1, 2, 3, 4, 5, 6, 7 cells merged. Then you need to do so. So let's create the formal layout first, TR and TR. How many cells are there? There are 7 cells. So you can say TD open, TD close. That is for 7 times. TD open, TD close. 1, 2, 3, 4, 5, 6, 6, 7. Right? That we can repeat 6 more times downwards. My page.html, the desktop, save. Okay. Okay. Let's copy this and paste this 6 more times. 1, 2, 3, 4, 5, 6. 6 more times. 1, 2, 3, 4, 5, 6. Okay, done. Save. Go to the desktop. And open it. My page dot HTML. Where are my files? I hope it should be there. Okay, here. Let me open. And you can see this layout now. This is not what we expected, but this is something that you can see now. And you can give some height to this table. Height you can calculate actually. Let's go to the exercise and try to calculate. 100 here, 40 here, 140, 140 plus 50 here, 140, 50, 190, 400, then 590, 60, then 500, sorry, 650 plus 100 is 700 altogether. 700 is the height that you have to calculate. Get it? And I think we are done with that. Let's see the preview of this, and here it is. Okay, 700 in height, 1160 in width. Okay. About the first row, yes, you can contribute. You can tell me about the first row. What is the condition? We have to merge how many? All 7 need to be merged, right? All 7 need to be merged. So how can we tell that?
Call span.
All span, exactly. Good. Very good. 7. Okay, then we have to erase all these, right? Because all these need to be merged. Clear?
Yes.
Save. Or there, refresh, the result is there. Okay, we are saved. Next, second line. Okay, how many cells are there? You can see in the middle 1, 2, 3, 4, 5. In the middle 1, 2, 3, 4, 5. In the corner there are 2, 6, 7. So all 7 are there. But there is a speciality. The first one and the last one merge downwards. Can you see? The first one merged downwards. How many rows it merged? Yes, how many rows?
3.
3 or 4?
4.
All right, here 1, 2, 3, 4 downwards. And here also 1, 2, 3, 4 downwards. Understood?
Yes.
Right, then great. So actually there are 7, altogether 7, right? 1, 2, 3, 4, 5, 6, 7. But from that 7 here, you need to row span how many rows? 4 rows. And the last one, you have to row span how many rows? 4.
4.
Right? To give the room, give the space, you need to erase 1, 2, 3, and 4 table data from that corner, and from the other corner also 1, 2, 3. Actually, not 4. Sorry, you have to erase 3 more, right? 3 more because the existing one is there. So let's keep that as it is. This one also erase accidentally now. So 3 more you need to erase. Understood?
Yes.
Okay. 1, 2, 3 more here. 1, 2, 3 more to give the room space. Refresh. Okay, you can see 4 are merged. 4 are merged. I think now you have the solution. You have the answer to the question that you made. You said that there is ambiguity in the 4th row. Can you fix it?
I have fixed it with you.
Ah, you fixed it already. Now all are okay.
Yes.
Very good. That's what I really need. Appreciate. Okay, then here 1, 2, 3, 4, 5. Remain as it is, and see here. Here you can see 1, 2, 3, 4, 5 are there, which can be merged together. And here also 1, 2, 3, 4, 5 are there, need to be merged together. Here also 5 merged together. So how you code that? Yes, go to the specific row, tell you need all span 5, right?
5. 5.
5 and erase all these because
Okay.
actually it's gone. Then here also all span 5, all these gone and all those will need to be erased. And here also the call span 5 and all these need to be erased. Save it. Yes.
Sir, in this part, 2 and 3 should be there.
Is it?
In the original one,
Is it? Let me clear it. Ah, yeah. This one, right? It has 2, right?
yes.
Correct. That is in the this one, right? This is actually then you have to call span 2, I think. Then again call span 3. Is it?
Yes.
Call span, yeah, 2 merge and 3 merge. Yes, I didn't see that. Sorry. Correct, exactly. Oh, yes, 5 are there. This one. Okay. The last one. It's easy now. I think we are done.
Yes.
Only need to fix the height and width. That is the part. Then last one, all merged. So that is similar to the first one. See, it's very easy, right? But even A-level students are struggling to do that because they don't know how this is actually happening. They are trying to code from top to bottom without knowing what exactly going on. That is the reason. But this is not difficult. Anyone can understand, but the thing is, you have to understand properly, right? Otherwise, a big issue. Then only you have to consider the width controlling and the height controlling. 100 there, 40 there, 50 there. Let's control TR height is 100 there, then 40, 50, 100, 40, 50, 140, 50, then 250, 60, 100, 250, 60, and 100 again. Save it, and I hope most of the things will be okay with this. Yes. Now you need to color that. To do that, you have to use
BG color.
yes, BG color. BG color. This is blue, and this is dark gray, light gray. Okay, let's use them. Let me color the entire table using BG color. COLR light blue. Save. The entire table will look like a blue color table. Oh, it's not too, it's too light. So we can create colors, right? Can you remember? Actually, you don't know because I didn't teach you. Today, let's learn. We can create colors. We can mix it. But we have to know the number systems as well as we have to know binary numbers, hexadecimal numbers. Do you know these things? Binary, hexadecimal?
No.
No. Okay, I'll teach you. What are these binaries? What are hexa? For the moment, I will keep okay, maybe navy blue, ocean blue, like that. We can name, but giving names, it's a limitation. It has a limit. It's not the proper color, but anyway, color. Okay, let's the royal blue. but cannot remember the color names like this. That is, okay, that one is okay, but cannot remember colors like this. Then this one actually, the one with 5, this cells you need to give individual colors. BG, COLOR equal, say, gray. The gray here and third, 5, 6. Save and top one is basically ash color, silver color, maybe. You can give it silver, gray. The last one is, it looks like silver. Okay, let's give that. But these are not the exact colors that we need. And finally, you can do something. Actually, finally, you can remove the border if you want. Make it 0 and you will not see any borders in there. Right here, see no borders is there, but still you will see that background colors. So shall we do this part?
Okay. What? What?
Are you done with this?
I colored it.
Is there anything affecting your?
It's not clear.
Which one to take?
Your
Coloring
voice
part.
is clear.
Oh, my voice. Is it okay now?
Yes.
Okay. So which part was not clear? So I think applying background color, is it okay?
I used black and gray and blue.
Black and doesn't matter, right? Doesn't matter. But okay, can you share your one? Let's see what has happened there. Let me share. Okay, now you can share. You can share your screen now. Okay. You have used black and gray colors and the blue color. Okay, right, great. So I couldn't tell few properties. And now what I'm going to do is I'm going to explain that properties to you. So one that I said is the border, right? Here, border. Border equals 0. So you will not see any borders there. But let's make border to 1 again. When border is 1, you can see these lines. And I can do another thing. I can say cell spacing. Cell spacing, let's say 10. Cell spacing means a gap between the cells. Can you see? Now
Yes.
there is a gap. This gap is added by putting cell spacing. That is important because even when you remove the border, when the border is 0, the cell spacing will work for us.
Yes.
It will let us separate. Or you can keep the border and give the cell spacing both, or you can even make cell spacing 0. Then what will happen? The border will be on the single line, no space. Right? Cell spacing is an important property. And also cell padding, this is actually used when you have a text inside the cell. Let's say you have some text here, my text. Okay, I'll put it here, my text, cell, it's here. You see my text. And if you need to give a gap, you can use cell padding. Cell padding. Let's say cell padding is 10. And the gap between the cell, the text, and the border here, this gap. The gap between, okay, let's make it 100, then it's clear. The gap between the cell text and the border is called cell padding, this one. The gap between the cell text and the border is called cell padding. Okay, cell spacing, cell padding. But
Yes.
actually for this one, you don't need cell padding. I'll make cell padding 0, cell spacing 0. So to make this appear in the string. And another thing to make this center line, so I'll use simple mechanism. I can say center, I can use center tag and close the center tag after the table. Then the entire table will be center aligned. You can see the entire table is center aligned because of that center tag. Let's do that changes quick.
Okay.
Finish.
Wait.
Okay.
Okay.
Okay, great. Then about the HTML colors, actually before learning that, as I said, if you already know about the number systems would be easy, but actually in this case, we need to learn a little bit about number systems, because without that knowledge, you won't understand how it happens, right? Therefore, let's go and learn about number system a little. Okay, you can see here, currently what we are using is decimal number system, that is called base 10. Decimal number system, base is 10. The digits that we are using are 0 to 9, right? The digits that we are using are 0 to 9. That is the normal thing that we are using day to day. That is the number system that we are using. Okay. Means, let's say your age. What's your age? You tell maybe 12, 13, 14. That is using these digits. And if you say the price of some good, that is also using this. And if you tell maybe the measurement or the time, still you are using these digits. Right? Date, time, you are using this digit. Here the date is Saturday 7, 14.29. That is using decimal.
Yes.
Right. So that is called the decimal number system. Can you remember the positional values?
Which?
Positional values of this, how it start? Can you remember the abacus? In school, maybe.
That unit 1,000 million.
No. In abacus, you measured like ones, tens, then hundreds, thousands.
Yes.
Right. You can say this is 7,000s, 800s, 2 tens, 20, and 3 ones. Can you remember the positional values then?
Yes.
This is actually ones, tens, hundreds, thousands. Actually, do you know about the power of some number? 10 to the power 0, 10 to the power 1, 10 to the power 2. Do you know such concept?
Yes.
Right. Okay. Then anyway, 1 is 10 to the power 0. Right? 10. Can you remember that? Any number to power 0 is 1.
We didn't have that.
Sorry, you didn't have that.
We didn't have that.
Right. Do or don't?
Don't.
Oh, you don't. You don't get that. Then what? Okay. Just forget about the powers. So you will learn in mathematics. Just forget about this part. Okay. But can you remember? I think you can remember this, right? This is ones.
Yes.
Tens, hundreds, thousands, right?
Yes.
When it comes to decimals, we call 0.1s, 0.01s, 0.001s. Okay with that?
Yes.
These are the points. So forget about the power. Power is that in mathematics we will learn that, but that is not a big thing. That is not a big thing. Any number to power 0. Okay, it's like this. So let's say any number to power 0, 10 to its power 0 is called 1. 10 to 1 is called 10. Right? 10 to 2, 10 to the power 2 is 10 into 10. Then what is 10 to the power 3?
10 into 10. 1,000?
Yes, 10 to the power 3 is 10 into 10 into 10. Very good. Exactly. 10 to the power 3 is equal to 10 into 10 into 10. That is 1,000, right?
Yes.
Here this is 100. 10 to the power 2 is 100. 10 to the power 3 is 10 to the 10 to the 10 into 10 into 10, which is 1,000. So 10 to the power 4. Now you know how it goes.
10,000.
10 to the power 4 is just 10,000. It is 10 into 10 into 10 into 10, which is 10,000. Correct. So I actually additionally, this is a mathematics lesson, but the thing is in maths also you will learn this. But I just wanted to tell you how things happen in. So I think it's good because you are learning mathematics as well as you are learning IT both together. That is an additional benefit, right? Anyway, any number to power -1. So I'll tell that part also. You can write down. This is extra thing now. So because I will erase this before that, you can write down. Not now. I'll give you time. Wait. So 10 to the power any number to power -1, right? So that we can write if any number to power -1 is given, that is equal to 1 divided by 10 to the power 1. Okay, what is that? 1 divided by 10 to the power 1, which is equal to 1 divided by 10, which is equal to 0.1. I think you are okay with division, right? 1 divided by 10 is 0.1. Okay, what is then 10 to the power -2?
0.01.
Yes, 10 to the power -2 is... What's your grade, Pute? You are in grade 8? Oh.
7.
7. That is 1 divided by... Okay, you will learn this in grade 8. I think you are going to grade 8, right? Next year?
This March.
This March, you are going to... oh, yeah. This March you are going to grade. Yes, you will learn there. Don't worry. So this is there. But anyway, just rough idea. But because before calculations, we need to know this, no? This is 1 divided by 100, which is equal to, as you said, 0.01. Okay, how the powers are made, how the positional values are. So can you write down, this is a bit unclear, but you can write down the heading number systems first. Then write decimal number systems. This is number 1. I'm writing the right in order, right? The second is the heading. Then you can write this note and you can show everything there up to here. And after that, the power explanation, please write down this separately. So please write, this is number 3, how the powers are generated. This is number 2, how minus powers are generated. So let's write down this. Is it difficult?
That fourth one.
No, I'm asking this concept, is it difficult or fourth one? And the third one, fourth one, is it difficult?
No.
No, okay. Because like if it is difficult, tell me, right? If you cannot understand, because like this is the mathematics subject, no? I don't know your maths level. But you for IT, you are okay. I know that IT subject is okay for you. I don't have any doubt about that. But you are new. I'm new to your mathematics area. Therefore, if anything difficult, please tell me. I can explain it again. Okay, please write down this 1, 2, second thing, write down this entire part up to here. Third thing, explain the powers, how powers are generated.
Okay.
This is read as, this is read as 10 to the power 0, right? This is how it is read. 10 to the power 0. 10 to the power 0, 10 to the power 1, 10 to the power 2. Okay, please write down it now. Right. Then, similar to that, there are some other bases. So, non-base to actually what we know is about decimal number. No? So, we day-to-day life, we are using decimal number system, right? Calculations, time, age, anything we are telling using decimal number system. But the thing is, but there are other number systems in computing world. So, one is binary, this one. Right? One is binary. And the next one is octal and next one is hexadecimal. What are these? What are these number systems? Let's learn. Right. In binary number system, only 2 symbols are there. In octal number system, 8 symbols are there. In hexadecimal number system, 16 symbols are there. In decimal, only 10 symbols, no? But in binary, there are 2. Octal, there are 8. Hexadecimal, there are 16. Right?
Yes.
Okay. Then why we need binary in computing? Can you recognize this icon? My drawings are a little bit ugly, I know that. Can you recognize this icon?
Yes.
Where you can see them?
Power button.
Power button, exactly. In the power button. Right? You can see that in the power button. Then why? Because power button has only 2 status, that is 1 and 0. Power button, you can do 2 things, no? Only one, on or off. You cannot half on or half off, no other things. If you press, it will turn on. If you press, it will turn off. Only 2 status. That is what electronics can understand. Electronic circuits can only understand 2 status, either on or off. Think about a bulb. Think about a bulb. Bulb can only understand 2 signals, on, off. A switch can understand 2 signals, on, off. A wire can understand 2 signals, having electricity, not having electricity. Therefore, the language of computing is binary. The language is computing is binary. It has only 2 status. That is why we learn binary in computing world. I hope that is clear. In computing world, there are 2 symbols only, on, off. Yes, no, on, off, switch on a bulb, switch on or off a bulb, switch on a switch, turn off a switch. Then another thing, having electricity in a wire, not having electricity in wire. Those are the 2 things that we can see. Okay. So therefore, binary is there in computing world. It has 2 symbols. Let me write a binary. This you have in grade 8. If you start grade 8, Actually, we have already started grade 8 classes for grade 8 students. So if you are also interested, you can join. It is in, that is a group class. It's in Monday. The time is Monday. English medium class is there from Monday. So 7 p.m. to 8 p.m. Only 1 hour class. Right? That is grade 8 ICT school syllabus. Right? If you are interested, you can just tell your father. Grade 8 ICT school syllabus. It is a new class, right? Because this year you are moving to grade 8. For them, we have started this. And you have this chapter in chapter number 1 for ICT, right? The binary number systems. This is extra thing. Anyway, so in this, okay, let's write an example. Example 1011. Okay, what is the positional value? There are 4 positions. Now you can guess the positional value. The first positional value is, yes, 2 to the power 0. 2 to the power, any number to power 0 is 1. And you can say 1 multiplied by this digit. This is 1. 1 into 1 is? 1 into 1 is? Yes. 1 multiplied by 1 is equal to 1. 1 multiplied by 1 is equal to 1. Right? Then this is 2 to the power 1. 2 to the power 1 is equal to what? What is
1
that?
to 2.
2 to the power 1 is 2, right? Then 2 into 1 is equal to 2. Then 2 to the power 3. Sorry, 2 to the power 2. What is 2 to the power 2?
2 into 2.
Yes, 2 into 2 is 4. 4 multiplied by this digit. What is this digit? It's 0, right? 0. So what is the value there?
4.
0. 0, 0, right? Then this is 2 to the power 3. What is 2 to the power 3?
6.
2 into 2 into 2.
8.
8. 2 into 2 into 2, it's 8. It's always double, right? Here always 10 times. Ones, tens, hundreds, thousands, 10,000s. 1 into 10 is 10. 10 into 10 is 100. 100 into 10 is 1,000. 1,000 into 10 is always 10 times. But here 2 times. 1 into 2 is 2. 2 into 2 is 4. 4 into 2 is 8. 2 times. Always it double. This into digit value is 1. That is
8.
8. Can you add them together?
What?
8 plus 2 plus 1. 0. 8 plus 0 plus 2 plus 1. What is the total?
11.
11. This is how 11 in decimal number system, you write small 10 there. 11 in decimal number system, you can represent in binary number system as 1, 0, 1, 1 in binary number system. Understood?
No.
No. Right. Okay. So can you remember the position? Is it okay? Positional values.
Yes.
Right. 1s, 2s, 4s, 8s. Okay. 1s, 2s, 4s, 8s. Then if it is something like this, 9, 8, 4. In 10 to the power, right? Base 10. In base 10. This is 1s, right?
Yeah.
This is 10s.
10.
This is
100.
hundreds. Right. Then similarly, you can write this one. 1 into 4 is 4. Here, 10 into 8 is 80. Next one, 100 into 9 is 900. Are you clear on that?
Yes.
What is the total then?
980.
984. When you add them together, you can get the total. That is 984. Okay, that is base 10. Here also you can do the same. But here you have binary numbers. Binary numbers are starting from 2 to the power 0, which is 1. 2 to the power 1 is 2. Then 4. Then 8. Then Similarly, you have to multiply the digit. Digit is 1. Then 1 into 1 is 1. 2 into 1. 2 into 1 is also. But 4 into 0. 4 into 0 is 0. Then 8 into 1. 8 into 1 is 8. Sorry, 8 into 1 is 8. Add them together. 8 plus 2 is 10. 10 plus 1 is 11. So 11. So total is 11. Understood?
Yes.
Right. Okay. So shall we try another one? Before trying that, I think you can write down this one now. Please write the heading binary number system. Then write this one. Then write this one. Binary number system. This part, this is number 1. You have to write this first. Okay, number 2. Show how you can convert a binary number to a decimal value.
Then what is this? This 10?
Which 10? That is the base. That is the base. So base means the number system. This is decimal number system. Base is 10, right? Binary number system base is
2.
Octal number system base is
8.
Hexadecimal number system base is
16.
That indicate which number system. It's like this is French or Japanese or Korean or Sinhala. We have languages like that, no? But here, these are all numbers, ne? The numbers are equal in all kind of number systems. We have same digits. Therefore, we should have a way to recognize. But Chinese, you have Chinese letter. Sinhala, you have Sinhala letter. Tamil, you have Tamil letter. But here, you don't. All are numbers. Therefore, we are writing the base to identify the number system. Understood?
Yes.
Base is 10, base is 2, and base is 8, base is 16. Okay, that is it. Number 1, please write down this. Number 2, please write down the heading. Convert binary to decimal. Convert binary to binary means base 2, right? Convert binary to decimal. Then after writing this heading, you can show this example, and then that will convert binary to decimal. Sorry. This is the binary number. For the base 2 number, you write small 2 there, right? To recognize that as base 2. Then take the digit value, convert it. So digit values are given here 1, 2, 4, 8, if more, 16, 32. All. And always when from the left to right, it is half. Half of 8 is 4. Half of 4 is 2. Half of 2 is 1. Half of 1 is 0.5. Half of that is 2.5. Half of that is 125. That is half. This side it is half. This side it is 2 times. 2 times of 125 is 25. 2 times of 25 is 0.5. 2 times of 0.5 is 1. 2 times of that is 2. 2 times of that is 4. 2 times of that is 8.
Yes.
It's mostly okay. Your answers and the conversions. Maybe there are some small mistake where we need to correct. So, okay, let's see what has happened there, right? So I think we need to practice a little, but so this is the first time that you already know. So this is like when you write this, first write this 1, 1, 0, 1, 0, 1, 0, 0, 1. Okay, then what you need to do? What you need to do is you need to first find the digit values. So this is 1s, 2s, 4s, 8s, 16s, 32s, 64s, 128. So zeros I will not consider. Therefore, this is 1. This is no. This is 8. That you need to add. Only ones and zeros, ne? Then 32s are not there. Then 64 is there. 8, 16, 32s are there. 32. 64 is not there. 128 is there. Let me add them together. 128 plus 32 is 160 plus 8 is 168 plus 1 is 169. The first answer that you have given is correct. Very good. That is 169. Okay. I think you did the same way and you got the answer. Good. So the second one. Okay, second one. The question says you need 110, 1110. Then you need to find the answers. This is 0, sorry, 1's not there, 2's are there, 4's there, 8's there, 16's not there, 32's there, 64's there. Let me add them together. 1 from 64, it is 64. 1 from 32, it is 32. Altogether, it's 96. None from 16. 1 from 8, 96 plus 8. 96 plus 8 is 104. 96, 804. 104 plus 4 is 108. 108 plus 2 is 110. And your second answer is also correct. Very good. So you have found that as well. So okay, very good. So let's go to the third one. Third one is 1 1 1 1 1 1 1 1. Okay, let me erase things from here and do the calculations. All ones 8 times guess 1 1 1 1 1 1 1 1 1 1 1 1. There you can see 1's are there, 2's are there, 4's are there, 8's are there, 16's there, 32's there, 64's there, 128 is also there. So let's add them together. 128 plus 64 is 192 plus 32 is 224 plus 16 is 240 plus 8 is 248 plus 4 is 252 plus 2 is 254 plus 1 is 255. So the answer is 255. That I think you have small mistake there, but I hope the method is correct, but small addition error, I guess. So the answer is 255. Okay. Other two are okay. The last one, please recheck. I think it is an addition error. Okay.
Okay.
All right. Then you need to know the other way also, how to convert a decimal number to a binary number. Right. So let's do that as well. Actually, other two things, octal and hexadecimal, you don't have much big calculations in this time, but I will tell you how the calculations happen. But actually, no need to calculate that. But for the moment, let's calculate converting decimal to binary. Write down the heading. Write down the heading. Converting decimal to binary. Converting decimal to binary. Because our real world things, what we see in the real world, mostly the sign decimal, as I said, the time, date, age, the price, all these things that we see, number plates, numbers in the buses, everywhere you can see decimals. That is our world. But the computer's world is binary. The computer's world is full of binaries, 1 zeros, yes, no, on, off signals. It is full of that. Therefore, you need to know how to convert our world to the computer's world. Now we know how to convert computer's world to our world, that is binary to decimal. But this one is converting our things to the computational, computer related things, that is binaries. So let's see, that is easy. Let's say there's a number is 16. Or let's say 19. Okay, what you need to do is you have to divide this 19 by the intended base. What is the base of binary?
10.
Base of binary is 2, right? 2, right? You have to divide from 2. You will forget this after some time, right? Therefore, please try to practice this maybe daily, not daily, at least weekly do one calculation, and because after some time you will forget. Anyway, this is an advantage because in grade 8 you have this subject. You have learned that then. You know the conversions, everything. Okay, 19 divided by 2. What is the answer?
9.5.
9.5. You are not going to write 0.5, right? Only 9. So what is remaining?
0.5.
Is it 0.5 or 1?
1.
9 into 2? 9 into 2 is?
18.
18. Then you have to tell remaining is 1, right?
Yes.
Because 9 into 2 is 18. 19 minus 18 is 1. Okay, 9 divided by 2. Is 4. 9 divided by 2 is 4. Okay, 9 divided by 2 is 4. Right. Actually, we are going to learn about one thing, but for do that, we are going to learn about the color theory. How colors are made in HTML, how colors are made in Photoshop and designing, how colors are made in programming. But to know that, we need to know this. That is why. Okay, then what remains?
1.
1, because 4 into 2 is 4 multiplied by 2 is 8. So 9 minus 8 is 1. Or again 1 remaining. 4 divided by 2.
2.
2. Anything remaining? No, it is 0. Exactly divisible because it is an even number. Exactly divisible. Divide again by 2. 2 divided by 2 is
1.
1. And the remaining is
0.
0. You can exactly divide. Okay, now all the digits are in ones and zeros. If all the digits are in ones and zeros, this can be read as a binary. You are reading from here to here, bottom to top. Actually, you can start from this digit 1 and then bottom to top. Then this is 10011 in binary. Actually, you can convert and see this. Let's convert and see. This is 1s, 2s, 1 plus 2 is 3, right? No 8s, no 4s, no 8s, 116. Then add them. 16 plus?
90.
Yes,
90.
16 plus 3 plus, sorry, 16 plus 2 plus 1, it is 90. So this is the proof, right? When you divide, you get the binary. When you write the binary, when you convert, you get the decimal. So you have a proof. So we can test anything, we can test. Okay, so let's write down the heading, convert in a decimal to binary, and then please write down this. Please draw this and show it, and you can show the proof also. Then try for this question. I will give 2 such examples. This time try to do all correctly. Right? Question 1 is this number. Let's say 127. Question 2, try to convert 4096, much bigger number. Question number 3 is let's try some small one, but a different number, 98. 3 numbers are there. Try to convert these decimal numbers to binaries. Okay, you can start now. That because if 1 bit error, therefore you have to be careful with that. Okay, first one, 127. 127 divided by 2. What is the answer? 127 divided by 2 is 63, right? 63 remaining. Okay. 63 divided by 2?
32.
Or 31? 31, right? Remaining 1. Check. 6. For 6 you have 3. For 3 you have only 1. Isn't it?
Yes.
After that the problem happened. Then 31 divided by 2 is 15, remaining 1. Divided by 2 is 7, remaining 1. Divided by 2 is 3, remaining 1. Divided by 2 is 1, remaining 1. So you can take from bottom to top. So the answer for this one is, here to here you can take, it is 1, 2, 3, 4, 5, 6, 7, 1, 1, 1, 1, 1, 1, 1 in binary. මෙතන වැරදුනානේ. මෙතන වැරදුනා මොකද උනේ? එතනින් පල්ලයට ඔක්කොම. After that, all these things got wrong, neither. That happened. It's okay, it's okay. Understood?
Yes.
Then the next one. Now, actually, we have a clear idea. After that, we can move the two tables, right? There's a pattern, and based on the pattern, it's very, very easy to do that. Okay, then 4096. 4096. So let's do that now. That is basically even number, so you can easily divide, and find the answer. Okay, let's do 4096. Divide by 2 is 2048, remaining 0. Divide by 2024, remaining 0. Divide by 512, remaining 0. 256, remaining 0. 128, remaining 0. 64, remaining 0. 32, remaining 0. 16, remaining 0. 8, remaining 0. 4, remaining 0. 2 remaining 0 and 1 remaining 0. So how many zeros?
12.
12. 1, 2, 3, 4, 5, 6, 7, 8, 19, 11, 12. Yes, 1 and 12 zeros. Your answer is correct. Then the next one is 98. 98. 98 divided by 2 is 4 and for 89 remaining 0. 49 divided by 2, 20, 24, remaining 1. Divide by 2 is 12, remaining 0. Divide by 2 is 6, remaining 0. 3, remaining 0. And 1. Divide by 2 is 1, remaining 1. So the answer is 1, 1, 0, 0, 0, 1, 0. Okay, that answer is also correct. Oh, last one. 1, 1, 0, 0, 0. Isn't that so? Make a better for the Patlila. You check it. Check it. 6 divided by 2 is 3. 3 divided by 2 is 1 remaining 1, right? Hello.
Hello.
So did you see the error here?
It is 0.
3 divided by 2
No.
is 1 remaining 1, right?
Yes.
දෙකෙන් බෙදුවම එකයි ඉතිරි වෙනවනේ එක. බෙදෙන්නේ නැහැනේ 3. 3 කියන්නේ ඔත්තේ සංඛ්‍යාවන්නේ. It's odd number, right?
Yes.
It's 1 remaining 1, right? එතකොට ඒක adjust වෙන්න ඕන නේද? This one. It should be 1, 1, 0, 0, 0, 1, 0. Other things are correct, but this be careful when it's easy, because when it is odd number, මේක ඔත්තේ නම් හැම වෙලේම එකක් ඉතුරු වෙනවා. If it is odd number, the next remaining will be 1. If it is odd number, next remaining is 1, right? So you can be careful that way. Okay. This is too easy. This is too easy, but don't don't be hurry and get it wrong. You understood this part, right? How to do that and all?
Yes.
Okay, that is for the decimals. Now let's go to the octals, hexadecimal. There is an easy way. Actually, in order to convert, you can create a table with these octals and hexa. Right, this is octal table. Octal is base 8, no? Then these are the digits, 0 to 7.
You are not clear.
Is it? Can you hear me now? Wait. Okay, can you hear me
Sir,
now?
you are not clear.
Yeah, can you hear me now? Slightly.
Yes.
Wait.
Yes.
Okay. You can, it's clear now, right?
Yes.
Okay. Then octal. Octal, what is the base?
8.
How many digits are there?
8.
8 digits, 0 to 7. Right? So
yes.
then you can see the values are going like 1s, 8s, 8 ගොඩවල් යන්නේ. එකේවා එක් වරකට 8යි, 8 වරකට 8 into 8, 64. 64 into 8, 512. Hexadecimals. What is the base?
60.
How many digits?
60.
16. Have I make a body visheshathya now? There's a speciality. 0 to 9 normal, right? But 10 you are not going to write 10. Why? Because you are using 1 and 0 again. Apa 1 0 pavichu venona metana. You are using 1 and 0. Therefore, you are not writing 10. Instead of that, you write 10 as A. Okay, 10 as A. Then 11B, 12C, 13D, 14E, 15F. Right, that is how we write the symbols of hexadecimal. Okay.
Okay.
And that is 16s, right? Ek is 10 godawal wenne. Ek godawal. It was a 10. 16 into 16 is 256. 256 into 16 is 4096. Likewise, it is 16 times. This is 8 times. Base 2 binary wala 2 times. Base 10 decimal 10 times. Base 2 binary 2 times. Right? Base 10 decimal 10 times. When base 8 octal 8 times. Base 16 hexadecimal 16 times. But in order to convert binary to octal, there is a table. Right? There's a table. See, this table has a pattern. Make it a pattern ekak tiyena. See the last digit. 0. After that 1. Again 0, 1, 0, 1, 0, 1. So can you see it's toggling. 0, 1, then 0, 1, again 0, 1, 0, 1. අර 10 පාදෙත් ඔය pattern එක තියෙනවා. 10 පාදේ කොහොමද යන්නේ? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. ඊට පස්සේ ආපහු 10 නේ. Means again 0. Then 11. Again 1, 12, again 2, 13, 14, 15, 16, 17, 18, 19. That pattern is there, but pattern gap is really high, right? 16, 17, 18. Hari, then metana me last digit එක බලන්න. See the last digit. Last digit is going from 0 to 9. Again 0 to 9. It was a 20 වලින් පටන් ගත්තම. Again 0 to 9. That pattern is there, right? But but binary වල එක ළඟ ළඟ තියෙනවා. In binary, because binary is only 2 numbers, 2 digits. 0, 1, 0, 1, 0, 1, 0, 1. Then 0, 0, double of that. 0, 0, 1, 1. 0, 0, 1, 1. Then 4 zeros, 4 ones. So this table you can easily remember because there's a pattern. Right? 0, 1, 0, 1, 0, 1, 0, 1. 0, 0, 1, 1, 0, 0, 1, 1. 4 zeros, 4 ones. And here also, in hexadecimal also the same table, but 16 patterns. What are these 16 patterns? 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. 16 times. Then 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 16 times. 4 zeros, 4 ones. 4 zeros, 4 ones. Then 8 zeros, 8 ones. That is how the hexadecimal table is made. So when you are converting from binary to hexa, easy, binary to octal, easy. I will tell how to do that easily. But before that, you need to write down these 2 number systems with their related symbols and also with the related. Okay, please write down this first, then write down this table, then write down this table. Okay, today a lot of work because we have to do the groundwork before doing our HTML part. But don't worry, I will make sure we will learn the practical today itself, how to make the colors. After writing this, I will tell you how to create the colors easily. Okay. Now, this challenge is, now you know the binaries, when you convert also you experience this binaries length, numbers are lengthier. 1, 2, 7, when you control, you got 1, 1, 1, 1, 1, 1, 1. Then 4096, when you convert, you got 1, 4 zeros, 4 zeros, 4 zeros. Altogether 5, 6, 7, 8, 9, 10, 11, 12 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 zeros. Okay, that is 4096. Then when you convert another number like 90, we got a lot of examples, and this one is 255. 1, 2, 3, 4, 5, 6, 7, 8. These numbers are lengthier. Lot of digits in binary. Therefore, as a strategy, computer scientists, they decided, okay, the electronic represent things in 1, 0, that is true. But when we are writing, so let's try it like this. Electronic represent things in 1, 0, but when you are writing, let's sort them according to this octal hexadecimal digits. So they decided to take 3 by 3 and map with octal. 3 is 111, the last 3 is 111. What is the octal value of 111? Is
7.
7. Okay, the next 3 is the next 3 digit. This is 111. The next 3 digit, again 111. So next you don't have 3 digit, therefore you can put zeros to the beginning and straight that 001. So then the next 3 digit 111, this is also 7. The next 3 digit is 001, it is 1. Therefore this is 177 in octal. See how it is easy that is. No need to calculate. Without calculating, you are writing this by the pattern identification. So can you tell me the same in hexadecimal? 1111111 in hexadecimal. Can you tell me? For last 4 is 1111 is F. The next 4 is
7.
7. Exactly. Very good. That is 7-4 in hexadecimal. This is easy. Once you know the binary, that means once you know the computer's way of representing that, converting that to hexa or converting that to octal is pretty easy one. Okay, tell me this one in hexadecimal. Hexadecimal, right? This one in hexadecimal. Last 4 is
0.
Okay. The next 4 is
0.
Yes. The next 4 is
0.
0. The next 4 is
1.
1. Then what is the hexadecimal value? It is 1000 in hexadecimal. Can you understand the way of converting?
Yes.
Okay, now we are safe. Within 2 minutes, we have to learn how to convert, how to get the colors. Okay, in computer, there are 3 basic colors. What are they? That you should know. Computer, there are 3 basic colors, red, green, blue, right? RGB. I think you have heard of that is called red, green, and blue. Right? In computer, there are 3 colors. Wait. Okay, here. In computer, there are 3 colors. Red, green, blue. Right? Color, the minimum color is 8 4s, 8 zeros. There are 8 digits. Minimum red is 8 zeros. Minimum green is binary valuing, right? This is in binary. 8 zeros. Minimum blue is 8. The maximum is 8. 8 ones. Can you remember the decimal values? All 0 means 0, right? 8 ones means what is in decimal? We did that. 11111111 in decimal. You did the calculation. 255, right? Can you remember? 255, right? Calculate kara neda 11111111. 251 aran tibbe ekak waradila.
Yes.
Right, that one. 255. right? So minimum is 0, the maximum is 255. Okay, then you have to write the code like this. Red code, green code, blue code, but you have to write in hexadecimal. Right, what is the minimum in hexadecimal? 0, 0, 0, 0, 0, 0, 0, 0. Hexadecimal වලින් කොහොමද ලියන්නේ? This 0 is 0. First 0 is also 0. This is 0, 0. Maximum කොහොමද ලියන්නේ? 1, 1, 1, 1, 1, 1, 1, 1. That is the maximum. In hexadecimal, it is?
FF.
FF. Exactly. Now you know how to represent the colors. This is minimum and maximum. Mari, තව ඕන තරම් තියෙනවා. දැන් මේකත් color එකක්. This is also color. මේක ඉතින් blue භාගයක් විතර තියෙනවා. ටිකක්. එතකොට මේකත් color එකක්. More blue. ඊට වැඩිය blue වැඩි. This is also a color. Most highest amount of blue. Right? So you have to represent red, green, blue in hexadecimal. Okay, now let's see the colors. First color, no red, no green, no blue. The color is black. No colors. Nothing. Black. No red, no green, no blue. Black. The second one, no red, but green is their maximum. Blue is not there. The color is green. Then red is there, no green, no blue. Red. Red is not there, green is not there, blue is there. That is blue. Understood?
Yes.
All right. You can give the color code with a hash in HTML. Now you have a clear picture. Okay, royal blue. That color is not the color, right? But you can put hash, no red, maximum, no green, maximum blue. No red, no green, maximum blue. And this is the color. Let's see the color. And this is the color. This is two blue names. The blue value again. So let me reduce. F1, it be darker. Let's add some green. Red, green. Let's add 50 green. 5 means hexadecimal 5, right?
Yes.
Okay. Okay. Some red also. Let's put some red. 5, some red also. Okay, this is the color that, but it looks purple. Let's reduce the red. 30. Let's increase the green. 8, 5, red, green, blue. Oh, that's nice. Now you have homework. What is that? Try to create colors. Try to create colors using hexadecimal digit. You know hexadecimal has digits starting from 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, then A, B, C, D, E, F. No more than F, right? The last is F.
Okay.
Right? Then this code has red, green, blue combination. So what is the way you can take a screenshot of this, how it is created? First red, second green, then blue. Red, green, blue. This is how you give it. Okay, that also you know. Right? Red, green, blue. Take a screenshot of that. Take a picture of that.
Okay.
Okay, then how to apply that? Take a picture of this one as well. Put hash. After the hash symbol, put the color code. Okay, let's say no green, no red, no green, no. Red, green, blue. Red and green together create the yellow color here. Red and green and blue maximum create white color because white color has all the colors. White light is divided to rainbow. So rainbow should create the white light. So white has all the colors, but red, green. Now you can combine red, green, blue, only green. Practice it. Okay.
Okay.
I know it is really little difficult, but you need to learn the number system. But it is an advantage, definite advantage. It is for mathematics and also for HTML in programming. In future, you will really need this. So remember these number systems. But we didn't learn hexa and octal much. That doesn't matter, but we know how to do that.
Okay.
Okay. Then have a nice day. Bye.
Do I want to download that
Notepad++. Yeah. Please download and install that. Notepad++, this one. Very small software. Please download, install that. That is easy. right?
Okay.
Then bye.
Have a nice day.